Hello everyone. Welcome to UIS. Let's discuss today's important topic. What is translunar injection (TLI)? A translunar injection (TLI) is a propulsive maneuver used to set a spacecraft on a trajectory that will cause it to arrive at the moon. The first space probe to attempt TLI was the Soviet Union's Luna 1 in 1959, which was designed to impact the moon. The TLI is performed when the spacecraft is at a specific point in its orbit known as the perigee or the closest point to Earth. The trans-lunar injection maneuver is a vital space travel technique used to launch a spacecraft from Earth's orbit and place it on a track beyond the moon. By firing its engines at this strategic moment, the spacecraft gains enough speed to break free from Earth's gravitational pull and embark on its journey toward the moon. For missions that involve sending spacecraft to points beyond Earth, including the moon or other planets in the solar system, such as manned missions or robotic probes, this maneuver is essential. A translunar injection, TLI, is a propulsive maneuver used to set a spacecraft on a trajectory that will cause it to arrive at the moon. Typical lunar transfer trajectories approximate Hohmann transfers, although low-energy transfers have also been used in some cases, as with the Hitin probe. For short-duration missions without significant perturbations from sources outside the Earth-Moon system, a fast Hohmann transfer is typically more practical. A spacecraft performs TLI to begin a lunar transfer from a low circular parking orbit around Earth. The large TLI burn, usually performed by a chemical rocket engine, increases the spacecraft's velocity, changing its orbit from a circular low Earth orbit to a highly eccentric orbit. As the spacecraft begins coasting on the lunar transfer arc, its trajectory approximates an elliptical orbit about the Earth with an apogee near to the radius of the Moon's orbit. The TLI burn is sized and timed to precisely target the Moon as it revolves around the Earth. The burn is timed so that the spacecraft nears apogee as the Moon approaches. Finally, the spacecraft enters the Moon's sphere of influence, making a hyperbolic lunar swingby. ISRO said it has transferred the IMS-1 satellite bus technology to Alpha Design Technologies Pvt. Ltd in a step towards enhancing private industry participation in the country's space sector. New Space India Limited, NSIL, the commercial arm of ISRO, facilitated the technology transfer through an agreement signed during an event held at the NSIL headquarters on 2 August, the space agency said on its website. The technology transfer documents were formally handed over by D. Radhakrishnan, Chairman and Managing Director of NSIL, to Colonel H. S. Shankar, retired Chairman and Managing Director of ADTL. ADTL is one of the two private players identified to receive the transfer of this technology through Interest Exploratory Note, IN, published by NSIL, it said. This transfer marks the beginning of satellite bus technologies developed by ISRO being transferred to private industries. Further, the PSLV is under productionization by a consortium of industries. Chandrayaan 3 consists of an indigenous lander module, LM, propulsion module, PM, and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry out in situ chemical analysis of the lunar surface during the course of its mobility. The lander and the rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan 3 is GSLV Mk3, which will place the integrated module in an elliptic parking orbit (EPO) of size 170 x 36,500 kilometers. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post-separation of lander module. The launcher identified for Chandrayaan 3 is GSLV Mk3, which will place the integrated module in an elliptic parking orbit (EPO) of size 170 x 36,500 kilometers. Thank you, everyone. Do subscribe to this channel. Use code SPLIVE to join Unacademy.